In this video, let's discuss what do we actually mean by a polynomial. Trust me, it's really simple. This Wikipedia definition might look complicated at first, but once we have a basic understanding of what a polynomial is, we can just look at any expression and identify which of them are polynomial and which are not. So before moving to some examples of polynomials, let us quickly understand what this definition says regarding this polynomial. So as per this Wikipedia definition, we have a polynomial is a expression, a mathematical expression. We are talking about any possible mathematical expression. So what is that condition that would make that expression a polynomial? Let's discuss that. So a polynomial is an expression consisting of variables, also called indeterminates, and coefficients. So we have two components here. One is variables and then we have coefficients. Coefficients, C-O-E-F-F-I-C-I-E-N-T-S, coefficients. What are variables? So variables, like you might have used it before, these are placeholders whose value would depend from context, from solutions to different situations. All the things that we have used like x, y, let me use the same color. X, Y, Z, P, Q, these are variables. And what are coefficients? So the numbers that are attached just before these variables, the numerical numbers to which these variables are multiplied, those are our coefficients. For example, if we would have 2y, so this 2 is the coefficient. Or if we have negative 5 upon 3a, so this negative 5 upon 3 is our coefficient. So now we have an idea of what is a variable and what is a coefficient. So it says that a polynomial is an expression that would definitely consist of variable and coefficient. Let's move on. That involves only the operations addition, subtraction, multiplication. There is no division. So it says that these variables and coefficients would only involve operations of addition, subtraction and multiplication, but no division. So for example, this would mean ki, let's say that we have 2x plus of 3y. This is very valid as per this definition. Or let's say that we have 4x square minus of 7 upon 3z. This is also valid because we have a subtraction. Or let's say that we have 5xy multiplied by 2.7m. This is also valid because we have multiplication. But what's not valid is, let's say that we have 42x upon 53y square. This is not valid because we have a division here. So a polynomial would never consist of such expressions, would never consist of any expression that would involve such division. It will only involve addition, subtraction and multiplication. Now let's come to the most important part here, and non-negative integer exponents of variables. Now it may look like a very gigantic or very weird term at first, but let me make you understand this easily. So it says that non-negative integer exponents of variables. So we are talking about the powers of variables. The powers of variables would be non-negative integer. It can either be positive integer or 0. It can never be a negative value. For example, let me show you what is valid and what is not valid. So different possibilities are 2x square. So here we have 2 as the exponent or the power of the variable. So this would be valid. Let's say we have 4 upon 3 y to the power 97. This is valid because we have 97, which is a positive integer as the power. So this would be valid. Don't worry about the coefficient. Coefficient can be anything. It can be any constant value. We are discussing about the exponent here. So 97 is a positive value, so this is acceptable. What is not acceptable? For example, let's say that we have negative 2.3 y to the power 4.5. This is not acceptable because this is a decimal. This is a non-integer value, so this is not accepted. Similarly, let's say that we have 4m to the power 5 by 6. This is not accepted because we have a fraction as the exponent or power of this variable. So this is also not accepted. So only thing that is accepted is that the power of this variable should be a non-negative integer. It can be something like 4x to the power 0, which is actually equal to 4, because any number to the power 0 or any variable to the power 0 is always equal to 1. So 4 times 1 is actually 4. So this is also acceptable because this is non-negative. So I hope this definition of polynomial is clear now. Let us see some examples. An example of a polynomial is a single polynomial of a single indeterminate, or rather call it variable to make things easier for us, of a single variable x is, see here, x square minus 4x plus 7. Now it satisfied all the criteria mentioned here. It involves subtraction and addition. It does not involve division, so condition satisfied. The power of this variable is 2, which is non-negative integer. The power of this variable x is again 1, which is again a non-negative integer. So this is acceptable. Hence, this would be a polynomial. Similarly, let's look at this example. We have variables and coefficients associated with addition, subtraction, and again addition. The powers of the variable are non-negative integer. Hence, this would be a polynomial. Let me quickly show you some examples that are not polynomials. For example, let's say we have 4x square times 7y to the power 5 divided by 45m to the power 2. This will not be a polynomial because we have a division. So this won't be a polynomial. Similarly, let's say that we have 44x square minus of 2 upon 3 x to the power 4 by 9 plus of y. This will not be a polynomial because the power of this variable is a fraction. This is not an integer, so this won't be a polynomial. Similarly, let's say that we have 2x minus of 5 square root of y. This will not be a polynomial because this power of y, square root of y is basically y to the power 1 by 2, which is, this power is not an integer. Hence, this will not be a polynomial. So now I think you have a good idea to actually understand, actually identify which mathematical expression will be a polynomial and which mathematical expression will not be a polynomial.